and now we are on 11.7, which is page 310 in your book 2, and we are going to see how partial fractions can be useful, okay, when we're integrating functions that look like this. So we have x minus 5 over x plus 1 times x minus 2 dx, okay? Now you haven't learned any methods where you can, which will help you to integrate this straight off. But what we can do is we can use partial fractions to split this up first and then see what is going to help us to integrate that, okay? So from chapter 1, you learned how to break this down into partial fractions. Okay, and I'm just going to quickly do this one here. Okay, so you normally will split it up like this and then cross multiply. Okay, because if that's the denominator, if you multiply everything each term by x plus 1 times x minus 2, this is what you're going to get. And I usually use the elimination method from here. So basically, what value of x is going to eliminate a? So I say let x equals 2. Then I plug 2 into all of this entire expression. I'll get 2 minus 5 equals, this will become 0, and I'll be left with b times 3. So I'm going to have minus 3 equals 3b, and that gives me b equals minus 1. Okay. Then I do the same, I think about what number is going to eliminate b, and that's x equals minus 1. So let x equals minus 1, plug that in. Minus 1 minus 5 equals a minus 1 minus 2. Minus 3a equals minus 6. A is equal to 2. Okay? And now this is going to be equivalent to, so basically now I'm going to have 2 over x plus 1 minus 1 over x minus 2 dx. Okay, so basically what I've done is I've split this question up into partial fractions, and now you all know how to integrate this, okay? So you are going to integrate this using ln, and you will get 2 ln x plus 1 minus ln x minus 2 plus c. Okay, and you can, you can leave it like that, or depending on what the question has asked you to do, you can simplify it. Okay, because this 2 becomes the power of x plus 1 using your power rule that you learned in chapter 14 of book 1. And then this can be further simplified, and it will look something like this. Okay, so this is your final answer for that question. Okay, example 2, and I've got this question here. Now this is just basically in this part of your exercise here, 11.7, you're actually doing quite a lot of revision for the partial fractions chapter. Okay, so if you remember, this will be a repeated root, or this is a repeated root, repeated expression in the denominator, and I'm going to split this up like this. So you'll have a over 2x plus 1 plus b over, and the way you do this is by writing b over x minus 2 once plus c over x minus 2 all squared. Okay, and once you've done that, you are going to get squared plus b 2x plus 1 x minus 2 plus c 2x plus 1. Okay, now let x equals 2. Okay, and if your x was equal, then what would you get? So 8x squared, actually let's just plug that in. 8 times 4 minus 19 times 2 plus 1 equals, this will become 0, this will become 0, and you'll just be left with this. So C times 5, okay, and you will get C equals minus 1, okay, if you solve that. Next, we are going to let x is equal to minus a half, okay, because we want to get rid of B and C, and we will be getting A. And if we did that, then our A is going to be 2. I'm not going to do that for you. Okay, now for these repeated type of partial fractions, you now have to think about one more substitution, okay, that will eliminate or that will get us to B, okay. We've already used 2, we've already used minus a half, so the next thing that we should do is we should use 0. We can use any variable, to be honest, but 0 is the easiest. Okay, so we'll say let x equal 0, and if we do that, it will get us b is equal to 3. Okay, now that we've got all of our variables, we're going to put it back in there, and we are actually going to be integrating this. Okay, so it splits up to be this. And now if I integrate it, I am going to get, so 2 stays where it is, ln 2x plus 1 divided by the derivative of the denominator. Okay, so this is using chain rule. This is using reverse chain rule. Okay, so you're going to have the divided by the derivative of the denominator, plus 3 ln x minus 2 minus, and now here actually I am going to rewrite this as x minus 2 to the power minus 2. Okay, and if I was to integrate that, I would get x minus 2 minus 1 divided by minus 1. Okay, so I will actually get plus 1 over x minus 2. Okay, and then this gives me ln 2x plus 1 plus 3 ln x minus 2 plus 1 over x minus 2 plus c. And this is our final answer. You can simplify it or you can just leave it like that, depending on what the question is asking you to do. Okay, in this question, we've got the situation where we have an improper algebraic fraction because the highest power of x in the numerator is 2 and the highest power of x in the denominator is also 2. So what we have to do is we've got to rewrite this as an improper algebraic fraction, and the way we do it is by doing one-step long division. Okay, so if I did one-step long division, how many 9x squares multiply to give 9x squares? So that's 1. I'll get 9x squared. Now multiply everything by this. I will get plus 0x minus 4, and that will get me nothing there. I will get minus 3x, and here I will get plus 6. Okay, and now I can rewrite this as as a mixed algebraic fraction. So I'm going to get 1 minus 3x plus 6 over 9x squared minus 4. Okay, so this is a mixed algebraic fraction, and from here actually what I can do is I can rewrite this as 1 plus 6 minus 3x over 9x squared minus 4. And I can easily integrate this 1, but I can't integrate this. Okay, so I've got to use partial fractions for this bit. So I am going to rewrite this like this. 3x minus 2, 3x plus 2, because remember this is difference of two squares, and this is how I am going to separate it. Okay. So I'm going to first of all, let x is equal to minus 2/3. And if I did that, then I would be able to get b. Okay, so my b is going to be minus 2. And the next thing I need to do is let x is equal to positive 2/3. And if I did that, I would get a is equal to 1. Sub that in there. So now I'm actually integrating 1 plus 1 over 3x minus 2 minus 2 over 3x plus 2. And I will get x plus ln 3x minus 2 divided by 3 minus 2 ln 3x plus 2 divided by 3. Okay, and my final answer then, and I can actually simplify this, is x plus 1/3 ln 3x minus 2 over 3x plus 2 squared plus c. And this squared comes from this 2 outside. Okay, so this 2 becomes a power of this 3x plus 2. Okay? Okay, and you can now actually do exercise 11G from these examples. Alright, and can I also just point out that in exercise 11, in exercise 11E, 2E actually requires the use of partial fractions, if I can remember correctly. So in 11E you actually needed partial fractions, okay? But you learn it in you learn it for 11G. Okay?